Hello everyone, welcome to another video. In this video today I'm going to be doing something which a few people have asked me to do, and that is going to be to show you how to connect up a UART reader to a PlayStation 5. So UART essentially is a diagnostic tool. It's included on the PlayStation 5, although it's not really meant to be accessible. It's only meant to be for internal diagnostics by Sony. But a few people have worked out how to obviously connect it up on a normal UART reader. So that's what I'm going to show you today. So there's a couple of things you're going to need for this. First of all, obviously, is going to be a PlayStation 5. And second of all, is going to be a UART reader. So this is the UART reader which I have. And you can see the model number there, if it'll ever go in focus. There we go. So it's SG2C2303. I bought this off of Amazon. I think it was around about £9.99. I'll leave a link to this one. This is a Type C version. But I'll leave a link to this one in the top pinned comment. And you can also get one from AliExpress. They're around about £1 on AliExpress. Just type in UART reader and you'll find it. And any UART reader realistically is going to do, but obviously there's a few different UART readers which give different features and things like that. So for example, this one is USB-C, or I've got a, it's a U-Green Type C to Type A converter, which I can use for that. So I could connect it up like that, or I can connect it straight up to my USB Type C cable, and that's how I normally use it. Another feature which you might not get on some devices is a 5 volt to 3.3 volt switcher, and that is a big must. It is a must that this is connected on 3.3 volts because that's what UART operates on, specifically on the PlayStation 5. This one's already got it. You can see here that it's got a switch here. I can flick from 5 volts to 3.3 and vice versa. Some of them might have, for example, an old PC style jumper pin or something like that as well. So be sure to get one with the switcher that's got the 3.3 volt voltage management included. So obviously you're going to need your PlayStation 5 board, and I don't know what's wrong with this board. I haven't got a clue. This is one that I bought to basically salvage for parts as part of a job lot. I buy them every couple of months or so whenever I need them. And I strip them down and sell the parts on the online store. Sometimes I do fix them for fun, for videos, or to, give to customers for board swaps and stuff like that if I can't fix their PlayStation 5. But for the most part, I'll just strip them down. I'll salvage mainly the HDMI encoder, the safe bridge, the SSD controller, the RAM, the power management chips, the Wi-Fi chip, that sort of stuff. And I'll sell all of that stuff on my online store, consolefix.shop. So if you do need parts for the PlayStation 5 or for any other console, check it out. I would really, really appreciate it. But basically, I don't know what could be wrong with this board. You can see we've got some liquid metal here, so I'm going to clean that up before I do anything else, because I don't want to cause any shorts or anything, and this is right by the APU, which is not good. So I'll clean this up just while I'm explaining basically what we need to do. So essentially UART is going to allow us to connect the console up to the PC, and that's going to allow us to basically read the error codes. For example, if we've got an no power issue, or if we've got, for example, the triple beep of death, which I've just done a video on, anything like that where there's an issue with the console, it's going to basically throw out an error code as long as the safe bridge is able to power up. So it throws out an error code, but it's obviously an internal error code that's only stored on the system. It's not actually shown to the user. So what we do is we connect up a UART reader and we connect that up to the PC. We use some software on the PC, and that basically gives us a error code which we can then compare against a database of known good or known error codes which we've basically built up over the past 12 months or so. The error codes are hit and miss. It doesn't necessarily mean that you're going to be able to fix it just because you can see an error code, because there are some error codes which we don't know the answer to. And it's like that with everything, obviously. We don't know everything. We're not absolute geniuses. I mean, there are some people that are absolute geniuses, but me, personally, no. So, basically, if you have an error code and you don't know what it is, and then, for example, you manage to figure it out without UART afterwards, then, you could submit that through Discord, or you could contact someone called Andyman on Twitter, and we can log the error codes for other people to use in the future. It all helps each of us out, basically. So that's kind of a community effort. But essentially what we need to do here, we've got 3 wires that we need to connect up. We don't need to connect up any power source because it's provided by the computer and also by the console itself as well. So basically what we need to do is we need to connect up 3 things. We need a ground, which is obvious. We need a ground for everything. But on top of that, we also need a transmit line and a receive line. So TX and RX, or TXD and RXD. So transmit data and receive data. RX on here needs to be connected to the TX on the board, and the TX on here, the TX on here needs to be connected to the RX on the board. So basically what you're doing is you're reversing the transmission and the receive, so as it's transmitting from one and receiving on the other. So you transmit it from the console, receive on the UART reader. Transmit from the UART reader, receive on the console. Hopefully that makes sense. But essentially that's what you need to do. So I've cleaned up the liquid metal here. So what I'm going to do is I'm going to just show you how to actually connect this up. So like I said, I've got 3 wires here. I've got a ground which I've marked as black, which I can solder to any ground point on the board. What I normally do is I'll normally either solder it to this little point here, because that's a ground, or if I've got the board out of the housing, so the metal surround that's on the console isn't there, I'll solder it to one of these points here. So if you look around the edge, where we've got this EMI shield in here, we've got a bunch of solder points. So there's a load of solder points everywhere. And essentially, it's going to leave less of a mess to solder to one of those points than it is to solder to, for example, to this ground pad here. So I always opt to go for the solder points whenever possible. You can connect it anywhere. You can get it connected to a crocodile clip and then just clip it to the chassis. You don't need to solder that wire, but you do need to solder these 2 wires, or these 2 wires rather, to these 2 points on the board. So if we look on my UART reader, I've got my blue and my yellow wire. My blue wire is going to indicate RX, and that needs to go to TX on the board, which is going to be this middle pin on the right hand side. So far right middle pin or pad, and then the other one is going to go to the one directly underneath it. So the middle pad here is TX on the board, and the bottom pad here is RX on the board. So we need to solder those, and we need to get a nice contact on them. So zooming right in then, you can see these pads. So we've got 10 pads here, right next to the connector for the LED ribbon. And it's only these 2 pads here, so just there, those 2, that we need. And then we obviously need, like I said, a ground point. I'll use this one right here. It doesn't really matter on this board because it's a scrap board, but just for the, just for the sake of showing you how I normally do it, I'll solder it to the point which I'll normally use. Now I'm going to take some leaded solder and my soldering iron. My soldering iron, I always keep it, if you're wondering, on 400 degrees Celsius. I never adjust my soldering iron, no matter what. I just leave it as it is and be happy with it. So I'll just put some leaded solder there. And I'm also going to retin these pads here, even though they've already got solder on, because that's going to make it easier to actually solder. So I'll just pop a bit of leaded solder on those pads. And then, like I said, my blue wire, which is going to be the RX wire, is going to go to the TX on the board, which is this one. So I'll solder that. It doesn't have to be a great connection. It doesn't have to be perfect. You want to get it nice if you can, but I wouldn't worry too much about it. And then the yellow wire, which is the TX wire, is going to go to RX on the board. So that's going to be this bottom pad here. So this is only the case for the EDM 010 and EDM 020 boards. So if you look on the board itself, you can see just by the USB ports, we've got the marking. This is EDM 010, and that is basically version 1. It's revision 1. You've got a lot of different boards. You've got EDM 010, 020, 030, 31, 32, 33, 34, 40, and 41, I believe. So what I'll do is I'll leave a screenshot up on the screen while I'm just doing this, and just basically show you where all of the contact points are for the different boards. Like I said, these are different for different boards, but for this one in particular, it's these pads, and also the same for the EDM 020 board as well. I'm just going to solder this ground wire here, and now that that's done, we're ready to connect this up to a power source and then to connect it up to the PC. So once you've actually got the wires connected to the board, once you've got your UART soldered, the process is essentially the same regardless of which board you've got. So you're going to need a power source. In this case, I'm going to use a standard power supply. And you're also going to need a USB cable to go to the computer. Like I said, this one here, I can use Type C. So I'll just grab my cable there. And I'm also just going to pop in the power cable to the power supply. Okay, I'm just going to verify really quickly that I've actually got 12 volts. Because like I said, I don't actually know what's wrong with this board. So I've got my multimeter just there. Always verify that you've actually got 12 volts coming in, just to make sure. And yep, I've got 12 volts, which means I haven't got a short on my 12 volt rail, which means, assuming the safe bridge is working, and this is very important, assuming the safe bridge is working, I should have a UART connection. The safe bridge has to be working. If you don't get a UART connection and you've got everything correct, everything set up on the PC correctly, then the chances are you might have a bad safe bridge, or you've got something shorted which is stopping the safe bridge from powering on. It's not a foolproof diagnostic tool. If your safe bridge isn't able to power on and go through its power cycle, you're not going to get a UART connection. So just keep that in mind. And on the PC, there is something that we're going to need, and that's called the PS5 WeTools by Andyman. This is completely free to download. I'll leave a link in the top pinned comment, and you'll just need to follow the installation guide that he's got for that. This video isn't about that. This video is about how to actually connect up and read the codes. So I'm going to load that up, and I'm going to run ps5wetool.py. As you can see here, I've got a terminal window where I can choose a couple of different options, or a few different options. I'm going to choose option number 2, which is terminal. And as you can see here, we've got COM1, COM7, COM8 and COM19. You've got to figure out where your UART tool is connected. So mine I know is COM19, so that's going to be option number 4. Yours may differ, so be sure to actually confirm that it's the correct one. Once we're in here, you can see that it's basically got a few options. We've got quick monitor, restart monitor, toggle EMC mode, show bytecodes and log to file. So you can log this to a file, but I never do. Control and E is what we're going to need to do now. So turn on EMC command mode. I believe, I'm not 100% sure, but I believe this is how we basically output to the screen. I could be wrong there. If someone knows, correct me. So Control and E, press enter and turn in EMC mode on. And that is correct. So what we want to do now is we want to verify that we've actually got a connection. So what I'm going to do is I'm going to unplug the power supply and I'm going to plug it back in. And if we've got a connection, if everything's okay, then we should see a message on the screen. So I'll just unplug that, give it a couple of seconds and plug it back in. And that just knocks off my monitor for some reason. But there we go. We've got a UART command ready code. So code 36, that means that we've actually got a UART connection. And we should be able to read the codes. So what we want to do is we want to type in ERRLOG space 0. And as you can see here, we've got an error code that says 8 zeros, or it says OK, 8 zeros. We want to ignore this completely. So just completely ignore this first section. So the first 8 bytes, ignore it. The error code that we want, the code that we want to read is this one. So the second 8 bytes, so in this case that's 80810001, that is your error code. That is the only thing that you want to be interested in. And what I've done is I've created a database of error codes which are known, with a brief description of what is actually wrong with the device based on that error code. So if we go to a browser here, and we're going to go to uartcodes.com. This is my website. It is still under construction. Most of the features don't work, of course, but you can search for an error code. Right now there are 1,422 error codes in the database. So if we just paste that error code in that we've just taken from the console, you'll see this is a common error code. I've typed it in before. And we have a RAM issue, apparently, on this. So, general power failure, periphery, GDDR6, APU, data line short. So that's telling me that there's well, it's a generic error code, but more specifically related to a power rail which is connected to either the RAM or the APU. But what we can also do is we can go for errorlog 1, and we've got another error code here. So C002002. So we can type that in. We can search that. VRM controller failure. So that's telling me that the voltage regulation management chip has failed. So basically there's a few different error codes. You can go all the way up to errorlog 9. So if we just type that in, and it's giving us the same error codes every time by the look of it. Now, here's the problem. If you have a bunch of error codes which were from, for example, a previous issue. So, for example, on the PlayStation 5, if you suddenly just lose power, that will throw out an error code. So, if you just pull the plug and don't shut it down correctly, that will throw out an error code on UART. And the issue with that is the fact that they don't overwrite. I think there are more than the 10 error codes that we read, but one thing that you realistically need to do is clear those error codes. So once you've grabbed a snapshot of the error codes which are being thrown out, what you want to do is you want to clear them. So if you just type in ERRLOG space clear, and there you go, you can see error log clear, B2, OK. So that's basically just cleared my error logs. So if I just type in error log 0 now, we've got nothing. It's all blank. So all of these bytes here have been wiped. And the reason for that is because now we can power cycle the console and basically just get a fresh error code, just to make sure 100% that the error code that we're receiving is up to date. So to power cycle the console, all you need to do is either unplug it and plug it back in, or just press the power button. Now in this case I don't have a power button, so I'm just going to short out the button. I'm not sure if it will actually log the code as soon as you plug power in or not, so I normally just cycle it. I don't have a power button connected at the minute, so all I'll do with that there is just short out the power button to ground, and that will basically just attempt to turn the console on. And now when we go back to the computer now, we should have another error code. There we go, 80810001. And if I go for errorlog 1, yeah, VRM failure. Alright, so those codes are up to date, but that is essentially it. That is all you need to do to basically read the codes on a computer and get a general idea of what might be wrong with the console. Like I said, this is not a foolproof plan, and it doesn't always work, but it could be a step in the right direction if you're stuck and can't figure out your issue. Now, one thing I do want to mention just before I finish the video is Andyman's tool isn't the be all and end all. There are other tools out there. However, you don't need to pay for tools in order to be able to do this. You don't need to pay for tools to be able to read the error codes. You can. I'm not saying don't. I'm just saying you don't need to. I'm not going to recommend any other tools because I haven't tried any other tools. All I've tried is this one from Andyman. This works great for me in conjunction with my own website, my own database. It works perfect. No issues. So yeah, I hope that gives you an idea of how to actually connect up UART for diagnostics. I fixed stacks of these consoles. If you've got, for example, a RAM issue, so if one of these 8 RAM chips have gone bad, it will tell you exactly which RAM chip it is. It will also give you a general idea, but it's up to you to interpret the error code and to basically figure it out from there. Like I said, it's not the be-all and end-all. It's not going to tell you, right, this is what's wrong, change this component. It's going to give you a general idea and say, this is where you can look. It's up to you to interpret it how you want to interpret it. If you get an error code and you're unsure, you can always go to, for example, my Discord or someone else's Discord, post on Reddit, whatever. Ask someone about the error code. Ask them if they've come across it. See if you can get some help. It's up to you to source the information. The information is there. It's available. But it's up to you what you do with it. So that's going to be it for now. Thank you very much for watching. If this video helped, give the video a thumbs up. Let me know what you think down in the comments down below. And as always, don't forget to subscribe and turn on the bell notifications so you don't miss any future videos. But other than that, thank you for watching, and I'll see you all in the next video. Bye for now.